Well, welcome again. So here is the problem. So attendance fluctuation. So you all have been a student or are students. You know that as you look around the room, many of your classmates are empty, right? You see the chair and some days they're there and some days they're not. And well, I'm sure some days you're there and some days you're not, right? The problem is that I have, for example, 30 students in a class, and I need to have a quiz, and so I print out 30 quizzes. I show up to class with 30 quizzes, and only 23 students are there, right? So what happens to the other 7 pieces of paper? I throw them away, or recycle them, right? But they get wasted. So my first semester at GRCC, this I save everything is the stack of papers that got wasted in one semester. This is useless paper. Is this a lot of paper? Here's a little context. This is a ream of paper. That is a ream and a quarter of paper. So effectively, the problem is I take this ream of paper, walk over to the trash can and throw it away. Now imagine doing that every semester as a faculty member. This is not a good use of resources. On top of that, there is a cost to print, right? There's ink, there's the machine, there's all those things. So that's about $100. Take out a $100 bill, tape it to the ream of paper, throw it in the trash can, right? Do this every semester. Obviously a problem. So I thought, you know what? I think I can fix this problem. I know there are some techniques to predict the demand for a product, and so I viewed attendance as a demand. So that was my goal. I have attendance fluctuation. Can I predict who's going to come to class, how many are going to come to class? First of all, let's talk about this scenario. If the number of pieces of paper I print is less than the number of the students, so I'm not going to waste, right? But the problem is, this can be dangerous because now maybe a student feels like they're being singled out because I don't have a paper for them. Or there's some confusion about, imagine exam day. I pass out the exams and I don't have an exam for 3 students. This is also not a good scenario. It's not wasting, but it's not a good scenario. I have to rush off somewhere and get a print. If it's at night where the library or the computer lab is locked, then I have to go all the way back to my office to print, right? So this can be also a dangerous scenario. And it's not really good, right? The worst problem though is if the number of prints is more than the number of students, then I get this problem, all this waste. So ideally, the ideal situation is the number of prints I make is exactly equal to the number of students. So let me make a note. Sometimes what happens is I overprint a couple of worksheets, right? So I hand this out on a Monday. A particular student wasn't there on Monday, and then on Wednesday they said, oh, Mr. Hadley, did we get a worksheet? And I say, yeah, we did, and then I give them the worksheet. So even though it didn't happen on the same day, they still got the worksheet. But as you all know, sometimes, even if I say, does everyone have worksheet 5.1? Everyone goes, yep, and then I still have 5 or 6 worksheets that get wasted because they just never get passed out. And then also certain things like there are group activity worksheets that it's for that day and that day only, right? There is no extended life. So my idea is the day, the number of prints, and the day, the number of students is exactly the same. Okay, so I'm going to forecast to try to predict the attendance, which I'm saying is the demand. Forecasting it is a certain process. We hope, this is a big word, we hope to forecast accurately. I'm viewing attendance and demand as the same thing. And at best, what I'm going to use is this forecasting model to seek reliable guidelines. Okay, let me show you a simple example of what I mean by hope. See, 4 plus 4 equals 8. Very easy, we all know this, right? I say 4 plus 4 is 8, not a problem. Well, here's the other thing. 4 plus 4 equals 6 plus some air, right? And so this is what we're really trying to do, is I'm going to say 4 plus 4 is equal to 6, and then I'm really trying to figure out my air, okay? And this is the fundamentals of most applied mathematics, is I'm going to guess at what the true value is plus or minus some air, okay? Is my air goes to 0, I get the actual number. That's the goal. Okay. So these guidelines are reliable to what I can do with my air. Types of forecasting. There's these qualitative forecasting methods. So we use our best judgment, we use opinion, we use experts' best guess, experience. Sometimes these get called seat of the pants, right? There's no math here, this is just my experience tells me. And I am going to use a little bit of that. There's a method that became famous by the Rand Corporation called the Delphi method. So they would make up a quite extensive questionnaire and send it out to experts in the field, collect that, and then have a forum. They sort of made that famous with predicting whether or not there was going to be a nuclear winter, right? They were forecasting how many years we have until World War end, right? That was sort of how it got first famous. But they also used this for market trends, forecasting of like housing markets and things like that. Then there's quantitative forecasting. That's where I'm most interested. And the two big types are time series analysis. So we're going to forecast specific times, in this case, each class. And there's also regression forecasting. I didn't really do regression forecasting. And the reason I didn't do much regression forecasting is, here at GRCC, for example, I have a class that has a cap of 30. I know for sure there will never be 31 students needing to have something printed, right? So my trend line for attendance is always going to be going down, or it's going to stay constant at some level. Because I'm never worried about more than the 30 students coming, or if I have a class of 32, more than 33 coming, then regression really is not going to do me much good, because I'm never going to fluctuate above that cap, right? So regression, we could use it, but I do think it would be sort of waste. So I use the time series analysis. Forecasting is looking ahead. There's short range forecasting, daily, monthly. In my case, I'm looking at daily forecasting. Some people use it for weekly. Then there's long range forecasting, looking years and years and years into the future. I'm not interested in that. I'm focusing on very short range, next class. Okay, the first kind of time series analysis forecasting. It's called naive forecasting. It's the easiest one, right? You all know how to do it. I look what happened last class and just do that again. 25 students showed up, 25 will come next time. 22 students showed up, 22 will come next time, right? That's naive. Very simple, naive forecasting, not very accurate, very big error, but it is a time series. The first one that is sort of useful is the moving average. So the moving average uses recent historical attendance to predict attendance demand. This method smooths out randomness, typically using the most 3 or 5 most recent attendance numbers. Here's the formula for the moving average. So the moving average is equal to the sum of all of the attendance demands divided by the number of things I want to average. So let's use an example with 3. So I'm going to look at the last 3 classes to predict what's going to happen next class. So this is an actual class, Calculus 1 class, data from October. So here is my first 3 numbers, 27 students, 25 students, 22 students. So I sum them up, divide by 3, and I get 25. So I'm forecasting that on Thursday night, 25 students are going to come. Okay? That's my guess. How many showed up? 25. My forecast was perfect. My error was 0. Okay? So now I move on to the next night. Now I'm going to forecast for Monday night using 25, 22, and the actual attendance from last time, 25. I put them in the formula, divide by 3, and I got 24.33. Okay, what do I do with 20.33? I look on the copy machine for the 0.33 button, right? That's a dumb joke, I know. So should I round up or round down? Round down? Round up?
Yes.
Round up, why? Well, because some poor student may get left with 0.33 is not going to work. But if I round up to 25, then I've covered that, right? So I've covered that problem. So I use this symbol to mean rounding up to 25. So this is the ceiling function, right? I'm rounding all my integers to the next highest integer. So I'm predicting for Monday night, 25. How many students showed up? 24. I overshot by 1. Not so bad. Now I've wasted 1 piece of paper. And then maybe eventually that student will collect that paper later on, but I've wasted this 1 piece of paper. Okay, so now the next night, now I'm going to add for the next Thursday night, I'm going to add 22, 25, 24 from the last 3 classes. And I add them all up, and I get 24. And how many students showed up? 19. Right? So I overshot again, but I overshot by 5. Okay, now you say, well, okay, so this is how many now? 6 pieces of paper you've wasted, which is not great. But if I'd have printed out 30 pieces every time, well, I wasted 3, I wasted 5, I wasted 8, I wasted 5, I wasted 6, right? So much better, much improvement. Here is a different class, the whole semester, attendance forecasted. The blue is doing averaging on the last 3 classes, and the red is averaging on the last 5 classes. And the black is the actual attendance. Okay? So you notice what happens, and this is generally the case. Also notice we're at 10 here, not at 0, right? So we start high, and attendance seems always to trend down. That's what happens, right?
The spikes the test days?
And that's exactly right. The spikes are the test days. Right? You also notice something that happens right before test days. For some reason, attendance seems to, we have a test on Thursday, so I guess I'm not going to come to class on Tuesday because we're not really going to do anything anyways, right? And then you see what happens after test days is always worse. Students, for some reason, do not show up the day after test. Maybe they're exhausted from taking the test, so next week, Monday, can't be bothered, right? This is a little bit from experience. My forecasting model would have shorted a few students the test, right? Which again, I want to avoid. So this is where I use my experience and my sort of seat of the pants knowledge to know that even though my forecast model says I should only print off about 20 or 18 or 19, I know that I'm probably going to have much higher attendance than that. And actually on that day, I may print off enough for every student no matter what, right? So that's where I'm taking my mathematical model and blending it with my experience, right? That I know there are certain situations that create that. There's another one over here too as well. Anybody have any idea what this day is right here? This one must be?
Last day to drop?
No, this is the last day before Thanksgiving break, right? So there's another one that the forecast is the forecast is the forecast, and then Thanksgiving break is coming, and then that class right before Thanksgiving break will have the same thing this semester with spring break. Right?
Was that also the day after your exam?
Yeah, so I have a double wham there, right?
Yeah.
So I had an exam, spring break, or Thanksgiving break. Improvement on the moving average is the weighted moving average. So the weighted moving average still uses recent attendance, but we assign weights to the most recent data. And this helps reflect fluctuations in attendance. So for example, if I'm keen on the fact that Mondays seem to have a different attendance than Wednesdays, I can sort of set my weights to reflect better on Mondays than on Wednesdays, right? I can do that kind of thing. Or if I say, well, what happened last class seems to reflect more what's going to happen next class than 2 classes ago, I can set my weights, right? So here's the formula. I sum up all the weights, and I sum up all of the demands. Now the weights have to equal 1. If all the weights are equal, by the way, it's the same as just the standard moving average, right? If all the weights are equal. So for example, I chose to do 10, 30, 60. They all add up to 1. I'm using the same October calculus example. And so I'm predicting Thursday night I'll have 23.4, which I ceilinged up to 24. And as you remember, I had 25 students come, so I overshot by 1. Did the same thing again. I get round up to 25, and I had 24 students come, so I overshot by 1 again. And then the last day, I end up with 19, right? So this 19 is bothering me every time, right? Where for some reason I kept having this problem, like not predicting very well what's happening here. Why 19 on that day? So here's the 2 weights I sort of used for the semester. I used one as 10, 25, 65, the other as 5, 15, and 80. And this is the blue weight. And so, again, the test day, the attendance right before test is low, so that makes my forecast go low, so I have to use my experience. But it does pretty well other places. This last one here, again, that's test days can be troublesome. Then here is putting more weight on what happened last class. And this does better, right? And I think here at GRCC, there seems to be some real consideration about what my trend is recent seems to be very important. Right? So I feel like students will miss clusters of days. They miss a Monday, Thursday, or Monday, Wednesday, Monday, Thursday, and then they come back the next week, right? So I feel like there seems to be some trend like that. Still very difficult to predict what's going to happen right before test days and test day, what happens after test days, right? This is the worst one. If I have a worksheet or handout or something after test day, I have a lot of waste there, right? Okay. I put them together, and that's what we get. Okay, exponential smoothing. Exponential smoothing uses the same historical attendance. It reacts to the most recent changes in attendance. It's a very popular technique. This is what many department stores use this. Gas stations use this to schedule how much fuel they need to have. Exponential smoothing is a very popular technique. It's popular because the math is easy to understand and it's very powerful. It's not hard to compute. Has a great track record of success, and it's the one I ended up using because it seemed to give me the most bang for results. So here's the formula. So it's recursive. So the future forecast is equal to alpha times the demand of the current day plus not alpha, 1 minus alpha, times the forecast of the current day. Alpha is this weight factor between 0 and 1. The higher you make alpha, the more sensitive you are to recent attendance. What's interesting about this is the forecast for the present class. This can be made any way you want. So you can use naive forecasting, you can use exponential smoothing forecasting, you can use weighted average forecasting, you can use moving average forecasting. And so the nice part about this model is I can use whatever forecast I want to start. So if I think I'm getting close to test time, what's going to happen after my first or second test when students tend to start really declining, I can use a different forecast to predict the start later on in the semester. It's a very flexible forecasting because the starting point is optional. Okay, so let's look at this scenario in October again. I'm using 40 weight, so I really have 40 and 60. And one technique to start your forecasting is you use the first day's data as both your demand and as your naive forecast for the next day. That's a very popular way to start. And the reason that's popular is because if I used my alpha equals 1, I'd have this being 0, and I'd be left with just the naive forecast, right? So it's an easy way to naively forecast the first day. So I work it out, and of course, what do you get as a forecast? Well, you get 27 plus 27 divided by 2, right? So you get 27 for the first forecast. Not very exciting there, right? But so managers understand that math. So what's our first forecast? We'll just look at what we did last time and write it down and say, oh, okay, I get that. So we're off and running, right? So then I plug that into the next one, and I get 26.2, which is a little bit high, but it's still overshot, so that's good. And then I get 24.52, putting the old forecast in, and the actual demand, the forecast from that day, I get 24.5. I do the next one, the actual demand, the forecast for that day, I get 24.7. And notice I would overprint by 1, right? And then, unfortunately, I still have this 19 creating problems, so I'm going to overprint by 5. Okay, that's the idea. This is my exponential smoothing for the whole semester for the class. And the red is 15%, so I'm looking at the most recent day having a 15% weight, and the 40% for the blue. It gets the nickname exponential smoothing really because as I make my weight smaller, this becomes more and more smooth like a line, right? Because it's looking at less of what happened last time and the more overall picture, right? That's a pretty good forecast. It's not so bad. We still have this problem with test days, right? We still have a really big overshoot right after test days. Still have the issue with Thanksgiving break, but that red trend line is pretty good. Not so bad. What's the best forecast? Well, again, this is an opinion, but what I did was chose what is called a stockout level of tolerance. So stockout is a term that retail uses when customers show up to your store to buy something, they have money, but you don't have that product in stock. So the worst case scenario is they go to your competitor and buy it at your competitor. This was considered death to retail for a long, long time. That has changed considerably now with the internet because people will go, for example, up to the front of the store and order it online at a kiosk. This is a big popular thing. So, for example, last night I was at Cabela's. Cabela's did not have what I wanted. The sales associate said, come up front with me, and he ordered it for me standing at the kiosk, and it'll be at my house today, right? So stock out is different, except for the warehouse has to have it, right? So there's still stock out, but now not at the local store, more at the warehouse level. So I want to make sure that I am not out of stock. And so in other words, I want to make sure that I have enough paper for my students, enough printouts, but not so much that I'm wasting, but that's the idea I thought of, oh, I can use the stock out technique. We have to decide on what's a service level. How willing are we to not have something for our customer? We decide on that. And I chose the 5% of the time. So in other words, 5% of the time I'm willing to say to a student, I'm sorry, I don't have a paper for you. You'll have to wait a second while I go make a copy. I decided 5%. And then I use the normal distribution to predict the variability of the students. So this is not forecasting, this is inventory control, but this is why I borrowed this, is because this is what's called the rate, the spot that you should order your product, and then this is the demand average times the amount of time it takes you to get the inventory to your store, plus this factor of willingness to not have enough, the service level, so the z-score for the service level, square root of the variance times of the demand times the amount of time it takes you. Well, here at GRCC, if I print it myself, the L is instantaneous. Right? I just walk to a machine and print it. If I use print services, it's a day. Right? If I don't do it on Friday, it's 2 days if I do it on Friday, but if I do it Wednesday at 2, then it definitely will be ready Thursday. Right? No problem. So it's a day. So here at GRCC, the L is equal to 1. So that makes things a lot easier. Also, by the way, if I take the square root of the variance, I get the standard deviation, and so I end up with this formula. So see what I have now? I have demand plus this, my willingness to short my students. And this is what I should consider my inventory, how much I print for my students. So this is the model I used. So the trick is, instead of knowing for sure what the demand is, how do I know the demand? I'm forecasting it. Right? That's the idea. Okay. So I put that with each of the forecasts. And at a 5% level, let's see if I can draw a reasonable normal distribution here. So the trick is, what do I choose for my mean? Well, here's the thing. I want the average amount of students who don't get service to be 0. That's what I want, right? So I choose that. That's what I want. Am I always going to get that? Of course not, but that's what I want. And then how much is my variance? Well, that's up to me, but I'm willing to waste a paper. So I'm going to vary by 1. Square root of 1 is 1. So standard deviation is 1. If I want a 95% situation on the left, so I'm going to be all of these filled in, off to infinity. And if I do 95%, I think this is 1.6 something, right? 1.65, something like that, right? You've taught, tutor stats, that's one you know all the time, right? If I did 1%, so I was 99%, I would have 2.6 something over here, right?
What's the 1.96?
Probably 90. No, I don't know what that is. I have no idea. So that's what I did. So in my model, with the 5% stock out, this is exponential smoothing, adding this 5%. So basically 1.65, I get this. If you look at the red one, like, I think that's pretty good, right? It's not perfect, of course, especially early in the semester. Look, I have, in this particular class, I had 24 students. That's the, only 24 students signed up. So obviously I'm not gonna print 26 things, right? So even in the beginning here, I'm still only gonna print 24, even though my forecast tells me to print more, right? Because I know it's not gonna go higher than that. The reason it's going higher than that is because I'm adding this, this overshot, right? Because I don't want to short students. And even without any intuition for test day, I'm still, if I round up, hitting it perfectly. Right? I did the same thing with 1%. So that's a 1% willingness to short a student an assignment or paper. but in practice I use the 5. Okay. So I wanted to go through all the classes. So this is a calculus class. This is a algebra 107 class. Notice that the scale is at 15. Then I had 3 sections of statistics. 3-section forecast. This is the ideal situation. This is ideal because in each section I have enrolled 30 students. That's a total of 90 students, right? At the start of the semester I have 90. As time goes on, I sort of, you officially get people withdrawing, so the number goes down. So I tell GRCC Print Services to print 70 papers, right? So really all I have to do is forecast the 3rd class. Because the first 2 classes, I have 70 in hand. The first 2 classes come and do whatever they do. Let's say they only use 50 papers from the first 2 classes. Well, I have 20 papers in hand. Now I just need to forecast the 3rd. If it says I need 26, I walk over to the printer, I print 6 papers, right? So that's even more of a savings because GRCC Print Services can do all 70 cheaper than I can do all 70, right? So this is the ideal situation. So if you look at the statistics class, just forecasting the 3rd class, I got that. So once again, I'm doing fairly well. What's that day? That's once again, the day right before Thanksgiving break, right after like our mini test. Right?
You put your test on that day.
Yeah, I need to, and then no one shows up. Can I take it when I get back from work? Right, so. Okay, so my results. So this is first semester. Waste. This is last semester waste. Okay, so put the 2 up there together. Like, I'm not happy I wasted this much, but I'm still happy with this. It's much improved, right? Very much improved. Okay, that's it. Any questions?
How many days did you have to go to the printer? Did you keep track of how many? I know it was kind of on there.
Yeah, so realistically it was about 5, right? And sometimes what it turns out to be is a student will say, especially if they missed and then want a worksheet or a quiz to make up. So I sort of learned to say, oh, I'd love for you to have that. Send me an email and I'll email it to you. Like, so that covered some of that. Mm-hmm. But especially for a worksheet that there's more in class, it was about 5 times, so which isn't too bad.
That is about 5%. Did you divide that by how much?
I did not actually figure it out, but it's pretty. I mean, it's pretty close. I think it would be a little less than 5. So I had to do it a few times.
5 times for all 3 sections?
For all 3, 4, 5 sections.
Oh, wow.
Yeah. So for 5 sections.
Were any of those tests?
No, for test I purposely made sure I overshot. So again, I worry about the students being a little anxious and then, oh, you have to wait for me to print the test. So I always overshot on test day on purpose. So it's a little bit of a price to pay, but.
Very, very early in my career, for reasons I don't recall, I did not print up enough copies. I'm sorry, did open enough copies for a test. That's really embarrassing. That's why
Yeah.
it only happened once.
Yeah.
Never happened.
Worksheets, students don't complain too much about that. Oh, just a minute, and I walk over to the computer lab and print off, 2. There was also a day, to confess, that I was supposed to print 7, and I forgot to print 7. So I showed up to class with 20 in hand from before. I needed to print 7 more, and I forgot, or thought I did and didn't, or left them on a copier. Who knows what happened to them? And then as it turned out that day, I believe there was 4 students that needed something. So I saved 3 effectively, right? But not on purpose, but it just happened, right? So
you consider changing the model slightly to maybe take out the test days from your model?
Yeah, and effectively, I really think the next iteration of the model will be, I use it Test days I ignore, skip that, don't even put them in the model. Yep. Look at it to predict, like, obviously I don't have 30 students anymore, but don't put them in the model
And it
anymore.
almost seems like the day after the test, maybe don't even include that error. Don't add the
What? Oh, for the day after, yeah.
Because the day after, you know it's going to be a little bit lower. So just do whatever the prediction is without the error.
Without that. I think too, maybe this also helped me in just my teaching style, because as I'm thinking about next semester, I'm thinking about, okay, days after test are low attendance, right? So for what I'm being considered due next semester, just from a teaching style is, okay, I'm gonna have something that is medium stakes for students to do, that they understand you want those points, you need to come to class that day. And I think that could help do that. And it's one of those things, until you actually see it out on the graph, I mean, you know that this happens, but until you actually see, you know, these dips after test, you go, like, consciously see them, like, oh, I could change something in my teaching style to help that. Maybe have, yeah, I mean, you know, the punish is a strong word, but that's what it is. Like, yeah. I remember as a student at Western, the Thursday before Thanksgiving break, Friday was no class on Friday, and our professor, we had this test that was worth like 60% of our grade, and he said, you will be here and you will take it, and there is no makeups. And I remember, like, that was the only day of class except for the first day that everyone was there. There was no seats. And there, I mean, there's something to that. Like, you have to come that day. That I'm sure he realized over the time that, you know, there are certain days people, well, we have spring break coming up, and the week before spring break, attendance starts to fizzle out. It really does. So
I think some people will probably, at a community college, I think some people will probably miss it either way.
Yeah,
Forget about that or something.
this
You're
happened.
You know, you're in grad school or something.
It's different, yeah,
A little bit more seriously.
for sure.
I have a question. When you printed the big stack, were you just printing however many people were in the section at that
Yes.
time, including people who had dropped?
No, so
Or-
you know, every week you go, oh, 2 people dropped, now I have 28,
Yeah.
so I just print
So you
28.
print
Yeah.
every time.
2 weeks later, 1 other person dropped, now I'm printing 27 every time.
Mhm.
Yep. So obviously, like, I have enough, but the result is waste, quite a bit of waste. So.
Have you talked to other professors about how they do this? I mean, I wonder if all professors usually just print off exactly how many are there, or maybe they're obviously probably not doing anything like this, but maybe they're saying, okay, there's 28 people in the class, but I know they all are not going to show up, so maybe I'm going to print 26 or 27.
So I have not directly talked to anyone, but my hope is that, you know, this sparked some of that conversation. I mean, that's one of the reasons I chose this topic is you know, the math community, we understand what's happening. We think, oh, that's a good idea. And I really hope that would spark some conversation among other communities. But,
Yeah. I mean,
yeah.
Do you ever get people ask for extra worksheets or extra quizzes?
I have had that, and if I have them, I'll give them to them, and that usually dwindles down on my actual error. And then on top of that, if I don't have one, I'll say, because inevitably someone had one, they lost it, now they want it again, right? And so that, you know, it's being used, it dwindles down in that error because I still have it in my folder. But inevitably, sometimes I will have to tell them, you know, send me an email, I'll send you one. And then you had your chance for me to print it, now it's your turn, you know, to print it off. But, and that does happen, you know, frequently enough. The worst though is, you know, quizzes, there's no makeup on quizzes in many of my classes. Well, I have these quizzes that just don't get used, and, you know, in that big stack, there's several quizzes in there that just never got used. So. The other is the syllabus. We pass out the syllabus on the first day. Well, you know, eventually those syllabuses all get dispatched because people lose them, people show up the 3rd day of class for the first time and you have one. So that's one of those things that you overprint, but eventually they get passed out to everybody. I have very few syllabuses. Yeah.
Have you ever considered having the students that are, you know, take your handouts, look at them during class, but they're not going to actually want them when they leave class? Give them a place to, like our
pass them
church
in?
does, where they put
Sure.
bulletins.
Like the right.
On the way out the door, they put the bulletins
For the
back
next
in
group,
and
right?
recycle,
Yeah,
you know,
yeah.
For the next service.
Yeah, the
or
next group,
whatever,
yeah.
you know?
That's a good idea, especially for the 3 section. Like, it's like if you know you're a crowd that's not really going to be doing anything with us.
Or prefer the email, the electronic copy that's out there on Blackboard.
Yeah.
You know.
No, I have not, like, directly thought of that. Occasionally, you know, as I'm walking around the room, there'll be some left, and I pick them up, and they do often get used again. But that's I haven't thought about having a program of that. This is a good idea to do that. Any other questions? I love math, and I love applied math. I apologize that there was no rigorous proofs for you to have to do today. But sometimes...
Yeah, I know some people here who would have really liked that.
even, sometimes the pretty blue chart and the pretty red chart do the job, I think. So. All right, well, thank you very much.